Okay, this video is answer is going to focus mostly on the use of the TI-83 to do this. But we've got this function 2 over the quantity divided by the quantity x plus 6. That's this graph right here. And we're supposed to estimate the instantaneous rate of change of this function at the point where x equals 3, which is 3 comma 2/9 actually. And what we're really doing is finding the slope or estimating the slope of this tangent line right here by calculating slopes of secant lines where the other point is close to 3 but not equal to 3. If I go to board 2, I've kind of expanded or narrowed in on the graph of this g of x function. That's still this red line here. The green dashed line is the tangent line, and this dark blue line is an example of one of the secant lines where x is 4. And this is the table right here that we want to mimic on the TI-84 or 83. This g of x sub 1 is actually the y value of the function at this given point, x sub 1. And I've listed some points getting closer and closer to 3. And then this column right here is the slope of the secant line, the change in y over the change in x, where the 3 comma 2/9 or 0.2222 is the fixed point where we want to find the instantaneous rate of change. So how do we do that? So I've brought up a TI-83 simulator here, but I've got to share my screen so you can see it. And now you should be able to see the TI-83 right there. I've turned it on. So here's what we're going to do. And you'll have to pause the video here and there and try to duplicate what's happening here. So first I want to create a function that matches g of x. So I go to the y equals, use the y equals tab, and I'm going to type 2 divided by, now here I have to use parentheses on the TI-83 to group the x plus 6 in the denominator. So there's the x right there, plus 6, right parentheses. So there's your g of x. Now, how do I get this slope formula into the calculator? Well, I'm going to, first of all, use parentheses to separate the numerator and denominator. So there's the left parentheses for the numerator. And here's the key. I want to take y sub 1 of x. And to do that, you have to click this vars button. And then tab over to y bars. And we want to remain positioned on the function button. And there's our list of y variables or y functions. So if I leave it positioned on y1 and hit enter, now I've got the y1. And I want to say y1 of x. So I put that in parentheses, and I'm going to subtract y1 of 3, like the g of 3 on Desmos. Got to go through the same thing. Vars, y vars, function, enter, use y1, left parentheses, 3, right parentheses, and then another right parentheses to group the numerator. And then finally divided by, got to use another grouping symbol. I'm going to put x minus 3. There's the left parentheses, x minus 3, right parentheses, enter. So now my two functions are entered, and now I want to use the table function to see what those two functions yield. It's hard to see this, but we want to hit second and then hit this graph button, but we're really invoking the table function up here. So second graph, and there it is. Well, not quite. These aren't the Y values or the X values that we want. So now we have to go to table set, which is second window, which is really this table set up here. So second table set. And what we're going to do is say for the independent variable X, we're going to ask for the variable values, the independent variable values. So I'll hit enter, and then I'll go back to table, second table, and now there aren't any variables there. So I can start entering some in the X column. So I'll say 4, enter. And that matches what we have on Desmos, 0.2 for g of x sub 1 and negative 0.222. And you can actually tab over to here to see the more precise value. Now I'll go back to the X column and I'll do 3.1. I'll do 3.5. And then I'll do a 3.1. And then I'll do a 3.001. And I can go on the other side of 3, 2.9, enter. And I'll just do the 2.999, 2.9999, real close. And if I want to see what that actual value is, I'll use these arrow keys to tab over here, negative 0.02469, 1632. Actually, the TI-83 gives a more precise decimal approximation. Okay, and by the way, that value as a fraction is really negative 2/81. Okay, I'm going to end the video there. If you have any questions, post a comment.